Right, so here I'm just showing a quick tutorial for making an RF choke from scratch. Here I've got an F240-43 toroid ferrite core ordered from Amazon, and a short length of RG58 coax cable. I have a plastic electronics block measuring 1 3/8 inch by 4 3/4 by 3 3/4. I have two PL259 male connectors and the reducers, as well as the UHF chassis PL239 female chassis with the 4 bolts on the other side. Because I'm impatient, I used the shortest screws I had, or the smallest screws I had available, but I would highly recommend using machine bolts and washers with nuts, as you'll be able to ground the coax from the inside rather than having to drill a hole like I did. A choke is actually a transformer, as the coils on one side of the toroid counter the coils on the other to negate or balance the common mode currents coming into or from the transceiver. Common mode just refers to the sum of all currents going in one direction, or all the current flowing into the device simultaneously. Without getting into particle physics, you're essentially choking the RF signal, which results in much cleaner signals both going in and out. I used the chart from the carinya.net website to calculate how many turns I would require. I'll put the link in the description. And I decided on 12 turns using RG58 coax with this FT240-43 toroid to cover the most bandwidth between 5 to 20 megahertz. As you'll see, my soldering is crude and I am impatient, but this just goes to show that what one man can do, so can another. At first I didn't really think I needed a choke, and I was making contacts, but once installed, the difference was night and day. I highly recommend making one as part of any rig. So originally I just wound a piece of wire around the toroid to get an estimate of length. And eventually I just bought about a 6-foot length of RG58. You want to make sure that it's the skinny stuff, not the wider stuff. It'll be impossible to turn. So here, once I've got the first turn started, I've got a zip tie to hold it in place. Just tightening it up and clipping that up with the side cutters. So here, I'm just quickly going through. I've got 6 full turns going through one side. And here I ran out of battery on the camera, so you can see that it's 6 on one side, and then it crosses over, and 6 on the other. And just spacing it, tightening it up, and another zip tie on the other side. And then cutting the excess off. Right, so here I'm measuring out the holes for the connectors. Get a scalpel. Scalpel's good. And just making sure that the height is good. One-eighth pilot hole. And the largest bit I had on hand was a 1/2 inch bit. You'll see that I have to remount the hole with the Dremel to make it wider. Insert Beavis and Butthead joke. And there you have it, with the 4 screws. Ran out of patience with doing camera work and soldering. So you can see here that I soldered on a 4 or 5 inch length of copper wire, fairly heavy gauge, soldered 2 ring terminals, which go to the outside mating surface of the female connector. And then I drilled a hole and they both go inside. Waterproofing is not a big issue for me because this is all temporary gear out in the field and not set permanently on some structure. You can see here the ring terminal passing through. And finally the finished product, where the dog's breakfast of a soldering job, where the core and the shields are both soldered to the ground and the connection points on the receiving terminals. Again, if I can do this, anybody can do this. Right, you can also see here that I've zap tied the toroid in place. Just drilled holes right through the back. I will probably end up attaching eye holes or eye bolts to suspend it. But along the way, I used the multimeter to test the solder at each point. And here it is plugged into the radio. So that feed line goes to the antenna on the roof, and the other feed line goes to the back of the radio. There's different configurations. The other thing that I soldered is a 3-foot length of RG58 with the 2 connections that you saw previously, which just allows me to attach it to and from the radio. So I hope this helped, and good luck. Maintain those perimeters.